Hello everyone! Welcome to our lesson for today. Today we are going to discuss more on generating patterns. But before anything else, I want you to focus and get your notebook and pen to take notes of the important details. Feel free to replay this lesson if there are things you do not understand. Let's recall. What is a sequence? A sequence, it means an order in which one thing follows another in succession. A sequence is an ordered list, denoted as A sub 1, A sub 2, A sub 3, A sub 4, and so on, depending if it is a finite set or an infinite set. Each member or element in the sequence is called term. This one is the first term, the second term, the third term, the fourth term, and so on. What is a finite sequence? A finite sequence contains a limited number of terms. This means it has an end or last term. Examples. Letter A. Days of the week. This is a finite sequence. Why? Because the days of the week contains 7 terms only, from Sunday until Saturday. Example letter B. First 10 positive perfect squares. Why do you think this sequence is finite? That's correct, because it only talks about the 10 positive perfect squares. 1 being the first term, 4 being the second term, and so on until 100 being the 10th positive perfect squares. How about infinite sequence? Infinite sequence contains a countless number of terms. The number of terms of the sequence continues without stopping, or it has no end term. Examples. Letter A. The counting numbers. 1, 2, 3, 4, 5, and so on. The 3 dots, which is called the ellipsis, indicates that the sequence continues without stopping, or it has no end term. Example letter B, the multiples of 5. 5, 10, 15, 20, 25, and so on. Again, the ellipsis indicates that the sequence continues, or it has no end term. Take note, sometimes a pattern in the sequence can be obtained and the sequence can be written using a general term or the end term. So let us learn finding several terms of a sequence given the general term. Example number 1. Find the first 4 terms of the sequence. A sub n is equal to 2n minus 1. Solution. To find the first term, let n equals to 1. So, a sub n is equal to 2n minus 1. Substitute the value of n, which is 1, and simplify. A sub 1 is equal to 2 times 1 is equal to 2, and copy minus 1. So the answer, or the first term, which is equal to 1. Repeat the same process for the second to fourth terms. Find the second term where n is equal to 2. Copy the given and substitute the value. Then you simplify. A sub 2 is equal to 2 times 2, which is 4. Copy minus 1. So the value of our second term is equal to 3. Find the third term, or the n is equal to 3. Again, copy the formula. Substitute the value of n, which is 3, and simplify. A sub 3 is equal to 2 times 3, 6. Copy minus 1. So the third term, or a sub 3, is equal to 5. Lastly, find the fourth term where n is equal to 4. Copy the formula, substitute the value, and then simplify. A sub 4 is equal to 2 times 4 is 8. Copy minus 1. So the value of our fourth term, which is a sub 4, is equal to 7. Conclusion. Therefore, the first four terms of the sequence are 1, 3, 5, 7. Given the general term a sub n is equal to 2n minus 1. Example number 2. What is the 10th term and the 15th term of the sequence? A sub n is equal to negative 1s raised to n all over n squared. Solution. To find the 10th term, let n be equal to 10. Using the general term given in the problem, substitute the value of n, which is 10, and then simplify. A sub 10 is equal to negative 1 raised to 10 will give us positive 1 all over 10 squared will give us 100. Then, the value of the 10th term in the sequence is equal to 1 over 100. If you find the number difficult to compute, you can use your calculator. Next, to find the 15th term, let n be equal to 15. Again, using the general term or formula given in the problem, substitute the value of n, which is 15, and then simplify. A sub 15 is equal to negative 1 raised to 15 will give us negative 1 all over 15 squared will give us 225. Then, the value of our 15th term in the sequence is equal to negative 1 over 225. Therefore, the 10th and 15th terms of the sequence are 1 over 100 and negative 1 over 225, respectively. How about if we are tasked the other way around? Finding the general term given several terms of the sequence. Example number 3. Write the general term of the sequence 5, 12, 19, 26, 33, and so on. Before we proceed with our solution, kindly observe the given sequence. Okay, solution. Did you notice that each term is 7 more than the previous term? That's right. We can search the pattern using a tabular form. So let us create a tabular form. In the table, you can see the term, the given, and the pattern. Now, the first term is 5, and the second term is 12. What can we say about the pattern? Correct. From the first term 5, you just need to add 7. How about the third term, which is 19? 5, which is the first term, you add 7 to get the second term, and you add another 7 to get the third term, which is 19. Our fourth term is 26. To get 26, from the first term 5, you added 7 to get the next term. You added another 7 to get the next term. And to get the fourth term, you added another 7. Our fifth term is 33. So from the first term 5, you added 7 to get the second term. You added 7 to get the third term. You added 7 to get the fourth term. And we are going to add 7 to get the fifth term. In general, the term is denoted as n. The given is denoted as a sub n. So how do we get the pattern or the general term? Observe this. That's right. The general term should be copy the first term 5 plus the 7, which is constant in each term, then multiplied by the number of term less than 1. So in general, a sub n is equal to 5 plus 7 times the quantity n minus 1. But this is not yet our final term or general term. Why? Because we still need to simplify. So a sub n is equal to copy 5 plus distribute 7 to the quantity n minus 1. So 7n minus 7. Now, we are going to add the similar terms. So a sub n is equal to, similar terms are 5 and 7. So 5 minus 7 is equal to negative 2. Copy the variable 7n. We can also write this one as a sub n is equal to variable first, which is 7n, then copy the constant minus 2. Therefore, the general term of the sequence given above is a sub n equals 7n minus 2. Example number 4. Write the general term of the sequence 2, 4, 8, 16, 32, and so on. Start by observing the sequence. Solution. Notice that each term is 2 times the previous term. We can search the pattern using a tabular form. Given in the table, term, the given number, and the pattern. The first term is 2, followed by the second term, which is 4, which is 2 times 2, 4. The third term is 8, and observe the pattern, 2 times 2 times 2. How about the fourth term, 16? The pattern here is 2 times 2 times 2 times 2, which is 16. The fifth term, which is 32. 32 is 2 times 2 times 2 times 2 and times 2. So what can we say about the general term using these patterns? As you can see, the exponent is the same as the number of terms. Here, there are 2, so the term is 2. Or you can say that if it is the fifth term, 2 should be raised to 5 to get the fifth term. So what is the general term? A sub n is equal to 2 raised to n. Therefore, the general term of the sequence 2, 4, 8, 16, 32, and so on is a sub n raised to 2 or equal to 2 raised to n. What have we learned today? We have learned 2 things. First, we have learned finding several terms of a sequence given the general term. Second, we have learned finding the general term given several terms of the sequence. Now it's your turn. Apply the concepts of the sequence you have learned today. Prepare yourself. Get your module and your pen to answer the exercises in the Module 1 Generate Patterns. You can use a calculator if you find the number difficult to compute. Good luck! See you in our next lesson!